All right, welcome back. We're on part 3 here of flip tiles. Now, one thing that I do want to add that I forgot about adding, and I realized when we were testing this last time, is we have no grid. So when somebody goes and tries to actually play this game, once the black tiles disappear, it's going to be really hard for them to know which square they're clicking on exactly. So this is something we got to add to Mind Puzzle. And I'm going to add it in just before we do the loop that fills the array. I'm going to paste that there. So what I did here is, this is what makes the grid for the squares. So it creates a new Greenfoot image that is cell size by cell size. Okay, we're going to make it so that it actually does this by cell size too. And cell size. Okay, and what's going to happen is it's going to create this image. It's going to draw out a rectangle that is, of course, the cell size by the cell size, so 75 by 75. And it's going to set it as the background image over and over again is what it's going to do. So let's look here and see our differences. So here we now have a grid, okay? So it's set the background and it's basically taken this rectangle image and drawn it over and over on the background for us. Okay, so that's that part. Now back to our regular scheduled programming. The tile act method. So this is kind of the heart of the game, but not really. That's more the mind puzzle. This is basically kind of where the tiles know whether they can be clicked or not. Again, I am going to copy this first little bit, okay, because these are notes here. This is just how to test the program. Of course, we'll do that. So let's do this first part. We're going to head over to the tiles act method, of course, okay, and inside part 1 is where we're probably going to start. I'm just put around here, okay. So if we are still on part 1, add to the part 1 counter, okay. So that we're going to do. First, I'm going to get rid of this comment and I'm going to put it below here. Okay, so if we're on part 1, we're going to add to the part 1 counter. So we're going to say counter. Oh, we called it P1 counter, right? Okay, so below P1 counter plus plus. Okay, great. So we've got that done. Pretty simple. Okay. The next thing it wants us to do is, if the counter gets to a point where we need to hide the squares, make them invisible and set the part 1 variable to false. Okay, so if the counter gets to a point where it needs to hide the squares, so we need to decide how long, okay, how long we're going to wait for part 1 to be over. So we need to say P1 counter. We're going to say if P1 counter gets to a certain point, then go on. So we're going to actually put up here how long we want P1 counter to last. And I'm going to call it private int hide time. Okay. And so I'm going to say the time at which we want to hide the black squares. So I think I had set this to, in the past I've done 75. All right, 75. So we'll go over here. If P1 counter is equal to 75, so if we've hit 75 iterations of the act method, it's time to hide all those squares. Okay, and in order to do this, we are going to set all their transparencies to 0. Okay, so I'm actually going to take this little bit here, just so we know where we're at again. It's nice to have notes throughout for when you're creating your own card games. Okay, and I'm going to move this here. P1 counter is equal to 75, then make them invisible. So set transparency to 0. And of course, we're in the tile class, but we still have to get that image. So get image dot set transparency to 0. okay? And set the part1 variable to false. So it's no longer part1, so we're going to set that to false. Awesome, so we've got that part, okay? Now we're going to compile. Oh, doesn't like something here. It looks like I missed a bracket. Yes, I have. So I'm going to check this down there. There we go. All right, and let's go back here. It says test this by running the program. The black square should disappear by as many iterations as you told part1 to last. So let's see here. We're going to compile, and our black square should disappear in around 75 iterations of the ACT method. Do we know exactly how long that is? No, but let's try it out anyways, just to see. They should disappear after a point in time. Awesome, so that's what we've got. Fantastic. Now we go back. Let's see, next part we are going to copy. So this is the part 2. This is when the user actually starts to click stuff, okay? So we're going into this else here. We're going to paste. Okay. If it is now part 2, check for a mouse click on this object, okay? So we'll put some of this information down here. We're not dealing with this yet. There, and I'm going to just comment that out. So check for a mouse click on this object. So if greenfoot dot mouse clicked this. Okay, so if there's been a mouse click, we then need to check a couple different things. Okay. If this object is a black square, then we're going to have to call the method correct click. So if black, okay, because that's our variable that's keeping track of whether it's a black square or not. Okay, if black equals true, we're then going to call correct click. So we can say get world dot correct click. Okay, now seems like it would be right, but we do have to cast get world by mind puzzle. We have to make it a mind puzzle, and that's because we need to know that we have to get a method from the specific mind puzzle class, not from the world class. So mind puzzle. Okay, so click, awesome. And then we also want to reveal the piece if it's actually true. So let's go and do that right now, actually. Okay, I know I had kind of screwed this up before and started filling it out, but reveal should only reveal this. If this is a black tile, we should make this reveal, okay? So if black equals true, okay, then we are going to get image and set transparency to 255. Okay, so we've got that. Now I'm going to compile this, see where it goes. Of course, I'm forgetting brackets again. Okay, but let's finish this up and then I'll compile it. How about that? Okay, so the next part is, this should be up here. Okay. If this isn't the right click, okay, so if it's not a black square, so we'll say else, okay, we are going to call wrong click. So we've got to call it the exact same way here, except we're going to call wrong click. Okay, and I'll stick that above, of course, to make sure that we know that that's what that is. Okay, great. So we've got that, and let's see. So our next test, I'll compile this. I forgot to do that. Oh, still missing that bracket there. Perfect, compile. Okay, we're happy now. test this program by running and trying to click on the right squares. If they are right, they should show up as black. So let's go here and let's try to be really good at our own game. Realistically, it's not that difficult when there's only 3 squares. So all across the bottom there, we're gonna run, okay? Black, 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 okay? Now let's try some wrong ones. Run, okay? And the second part of the game, no, only the black ones will show up, okay? That's what we should have. So I'm gonna reset this one more time and let's try to click things before. So I'm gonna press run, try to click things before. Okay, and nothing happens when we click before and then we click. Awesome. So before the part 1 time is up. So part 1's working, we got squares showing up, we have called right and wrong click. Nothing's really happening there yet, so we'll have to test that in the next section. But for now, we're getting there. We're very close. The last little bit is going to be actually calling this result panel and having the right and wrong results show up. And we'll do that in the next section.